Okay, our objective today, we're going to use the area addition postulate to find the areas of composite figures. Use the area addition postulate to find the areas of composite figures. Okay, so what is a composite figure? A composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. So you get a bunch of these little smaller shapes, you sort of put them together, and you get a composite shape. That's all it is. Made up of simple shapes, triangles, rectangles, trapezoids, and circles. So let's do a problem. So the first one, let me slide it over, it's asking us to find the area of this shape. Now, I always tell my tax kids again, you know, there's nothing on the formula chart that tells you how to find the area of this shape. But I can break this up. I can break it up into two smaller pieces, and I can find the area of the two smaller pieces. So for example, I can cut it like that. And now I have two smaller rectangles. So that's what I'm going to put in this little box over here. So what are the dimensions of just that top rectangle? I redrew it right there. So that is just my top rectangle. And then what are the dimensions of my bottom rectangle? It's 4 this way, and it is 3 from here to here, and it's also 3 from there to there. So my bottom rectangle has an area of 4 by 6. So all I did was I broke it up. I just took the bigger chunk that they give us, that larger piece, and I broke it up into two smaller rectangles. That top piece it told us was 3 by 4. It's 3 this way and 4 down, so it's 3 by 4. The bottom piece, we had a little bit of work to do. It did tell us that this piece was 4, and how long is it all the way across? Well, if it's 3 from there to there and 3 from there to there, it must be 6 all the way across. So then I just found the area of this rectangle. Length times width gives me 4 times 3, which is 12. Area of this rectangle, 6 times 4, which is 24. So the area of the little rectangle is 12, area of the big rectangle is 24, and then we just add them up to get the area of the whole shape. 12 plus 24 is equal to 36 inches squared. That's the area of that shape. Okay, so now we're going to do something similar here. So at first glance, maybe we only see an arrow. Look at it again. Okay, now maybe we see a triangle on top. There's my triangle, and just a rectangle on the bottom. So I just redrew my picture. I just drew the triangle. So there's my triangle. So where did my dimensions come from? The base, how far is it from here to here? I'm saying it's 9. Okay, where does that come from? It's 2.5 from here to here. It's 4 from there to there. I got that from the 4 at the bottom. And then it's 2.5 there. So 2.5 plus 4 plus 2.5 tells me that the base is equal to 9. And the height, I'm saying, is 3. Well, if it's 9 all the way from the top to the bottom, and it's 6 from here to here, then this piece must be 3. So that's where the 3 is coming from. Now I just do area of a triangle, it's base times height divided by 2. Plug in my numbers. 9 times 3 divided by 2, and I get 27 over 2 as the area of the triangle. Okay, then I just worked on the rectangle. The rectangle on the bottom is just 6 by 4. It's 6 this way, and it's 4 that way. So the area of my rectangle is length times width, which is 6 times 4, which is 24. So the total area, add those two up, 27 over 2 plus 24, is equal to 37.5 inches squared. Okay, let's go to the back. So there's another way you can do composite figures, is by subtracting. So most of the time these kind of problems involve sort of like there's a hole being cut out of the shape. So you can still do it the other way. You can still break it up and find the area of the smaller pieces and add them up, but sometimes it is easier to find the area of the whole shape and then just subtract the area of the whole. For example, on this one, let's say, I could have broken it up. I could have found the area of this rectangle, found the area of this rectangle, found the area of that rectangle, and then just added them all up. You can do that. Nothing wrong with doing it that way. Sometimes it's easier to do it another way. So this one, let's find the area of the whole rectangle, the big rectangle. It's 9 this way, and it's 12 that way. So the area of the rectangle is 9 times 12, or 108 inches squared. But this 108 is the area of the whole thing. But I do have a hole being cut out of this piece. Well, what's the area of the hole? Well, it's 4 from here to here. It's 12 all the way across the bottom. And it's 4 from there to there. It's 4 from there to there, which means this must also be 4. So the area of that hole, it's 4 by 4, is 16. So the area of the hole is 4 by 4, 16. So 108 is the area of the rectangle. 16 is the area of the hole. So all I have to do is subtract. 108 minus 16 gives me, 92 inches squared. Oh, I did write it there. 92 inches squared. This one, they didn't give us any numbers, so I just made up my own. I called this length 4, I called this length 4, I called that 6, that one 6, and I called all these little small ones 1. So it's 1 from there to there, it's 1 from there to there, 1 there, 1 there, and so on. So I'm going to do it the same way I did the last one. So I'm going to take 8 times 6. Okay, where's the 8 and the 6 coming from? So I found the length. Imagine, let's see if I can make some dotted lines here. So imagine I had this big rectangle. So what is the length and the width of that big rectangle? Well, if it is 6 from here to here, and then it's 1 from there to there, it's 8 for the length. And if it's 4 from there to there, but it's 1 there, then it's 6 this way. So my width is 6, my length is 8, so I have 8 times 6, 48. Again, but that's the area of the whole rectangle. But I then have to subtract the area of each one of these little squares, these little holes. But each one of these holes is 1 by 1. So the area of this hole, this square, is 1. Area of this hole is 1. Area is 1. Area is 1. So I have 4 squares of an area of 1. So that's an area of 4. So that's the area of the whole rectangle minus the area of the 4 holes, and I get 44, I guess I should call it units squared. These down below we'll talk about in class. That's all I got for you.